Welcome friends. Today we will be studying about sampling and non-sampling errors. In our previous videos we have seen about different techniques of sampling and we were discussing about random sampling technique and non-random sampling techniques. And today let us look at what types of error that comes in a survey due to sampling and when we don't perform sampling, then what type of errors, it is when we perform complete enumeration, then what type of errors come into existence. The sampling error is present only in sample surveys, but the in census survey sampling error is not there, but non-sampling error is present in census surveys. Non-sampling error is also present in sample surveys. So in sample survey has to take the burden of both sampling and non-sampling error. However, in complete enumeration or in census surveys, the only type of error that can creep in is due to non-sampling error. Now let us see what is sampling error, how much serious it is, and what it is uh, all about. We also bring into a comparison between sampling error and non-sampling error, and we also define sampling error, we define non-sampling error. So in this process, in this presentation, we will be covering about sampling error, we'll be telling about non-sampling error, we will look into a comparison between sampling error and non-sampling errors so far as surveys are concerned. Okay, so let us first have a screen about the sampling error. Well friends, sampling error occurs due to unrepresentativeness of the sample selected for observation. So suppose I am a researcher and I am selecting a sample from a population. So this is maybe my population. From population I select randomly or non-randomly, whatever, a sample here. Now this sample, with studying this sample to find out matters related to the population. That means we will look into the sample, but our conclusion in this is on the population. So looking to the this, you may tell that there is a way in which we are looking to the population through the sample. Now for different purposes or to get a better understanding of the population, you want your sample to be heterogeneous. That means your sample should be a very nice representative of the population. Representative of the population. Some people tell that sampling is a part of the population. Undoubtedly it is. But the thing is that along with being a part, it should represent the population. For example, suppose I collect some observation from here and call it, this is my sample. Sample, say I call it sample 1. So this is my sample 1. But the problem with this sample is that it does not represent those units which are in this location, which might have other characteristics. And so your sample will be a representing this part of the population only. If there is some variation in the other parts, that will not be included in the sample. However, if your sample is homogeneous type, then this would do a good job. That is happening when you go for a blood test. The sister who comes actually takes out blood from a part of your body, and that actually tells the entire story of the problems that you have medically, because this can be executed because the blood is a homogeneous fluid. But when we go for social science surveys, marketing research and other type of surveys where we speak of human beings who are varied in their nature, in their physique, in their intellect, in their understanding, in the way they live, and so there is quite a lot of diversity, and hence we cannot afford to have a sample this. Now when I study and sample, the error that will come into existence in my results, my study, that is called as a sample error. Now non-sampling error, along with the sampling error comes out, obviously there is non-sampling error. Non-sampling error also simultaneously exists in a survey, whether it is a sample survey or an complete enumeration or census survey. In census survey, this is not there. Sampling error is not there, but this is present both in sample as well as both in sample survey and in census survey. Non-sampling error. Now, what is non-sampling error? This is an error which arises due to a human error, such as error in identifying the problem, error in definition, error in the procedure used for data collection, etc. That means these are the errors where sampling has nothing to do, nothing related to the sample, but maybe it is related to the method, maybe it is related to some other types of human error beyond the sample. So this is the basic difference between sampling error and non-sampling error. Obviously, if you are a good researcher, if you are ideally, we will try to decrease both the types of error. But that sampling error should not be there, and the sampling error should be, so we should draw a sample in such a way that it represents the population very nicely. But often it does not happen so. And when you go for non-sampling error, when you go for a complete enumeration, or even in sample surveys, there are many human errors which cannot be, because all things cannot be processed with the help of electronic gadgets. Somewhere in surveys human intervention shall be there, because ultimately you are collecting the data from the human beings. You may minimize to lot of types of error by using electronic gadgets or electronic means, but even then, ultimately the response is given by human beings. Maybe it is collected electronically, automated process, but it is ultimately collected, means response is given by human beings. And also procedural decisions are taken. Now, if there is some defects in the procedural decision, then obviously non-sampling error will creep in. Now, suppose I want to, what is actually error? What do I mean by error? Suppose this is my population and I am interested in a population characteristic mu. So this is generally this is a representative population mean. You think that this is a population characteristic mean. And for this, suppose we take a sample characteristic, say x bar, and I am telling that x bar I am using as an estimate of mu. That means you are studying the sample. From the sample, you are getting this x bar, and with the x bar, you are getting an estimate of mu. Now, this difference, x bar minus mu, this is called as the error. This is called as the error. Now, this error, as you understand, can be positive also, can be negative also. If this error is positive, it means that you have overestimated the value of mu. If this is negative, it means this value, entire x bar minus mu, then you have underestimated the mean value. Some people, instead of having this, they speak about taking a modulus. That is, I am interested in the magnitude of the error, not its direction. That is minus or plus. That is, I am not interested, but I am interested in the magnitude of the error. So some people tell like this. Some people take a square of this. So this way they try to eliminate the sign of the error in a natural process. So these are different ways in which error. This error, that is the total value of these, will come out of both sampling error and non-sampling error. This is a combination of both giving us this. However, if you perform census surveys, then this might not be there. Only non-sampling error are there. Sampling error, if you want to define sampling error, we can tell that sampling error denotes a statistical error arising out of a certain sample selected, which is unrepresentative of the population of interest. In keeping in very simple words, sampling error is the error which occurs when the sample selected does not contain the true characteristics of the whole population. So sampling error, we can write it in this way. Sampling error is that type of error which creeps in a survey when the selected sample does not represent the population characteristics properly. So these you can take as the definition of sampling error. However, I will be providing you some study materials in this regard. Okay. Now, uh, the main reason why this sampling error comes into existence is that uh, the individual units which are actually sampled or taken care of from the or drawn from the population, the units may have individual variances. Moreover, it may so happen that the sampling design itself was defective. The units that was demarcated was not proper. For example, suppose I am looking into a town and I want to survey a population, survey a sample, take a sample from this sample of households from the town. Suppose the map of the town is like this. Suppose this is the map of the town, the municipal area of the town, but there are some areas which are in the periphery, which has grown up recently with many people staying around. You'll see in big cities that near the big cities there are some big residential areas growing up, and they are so close to the city, and even the malls and other things which we expecting to see in a city are also there because there is a huge population in the residential area. But statistically speaking, or means geographically, this is not these buildings which have grown up in the periphery, giving the form of a town, or rather pushing the boundaries of the town, is not technically the part of the town, because your town municipal area is defined here. Now, when you take the sample, you consider some households from these parts also. From these parts also we consider some household. So suppose I consider this one household from here, two household from this building, three from this, and now I start studying my sample. So I have a sample here, and in my sample I have considered several such families or households. Now these households have some members who are not actually a resident of this population, does not come under the population which we are studying. So ultimately the estimates that you get from this sample about the population will have lot of error in it, because you have included by mistake some of the units which are not a part of the population. Now sometimes what happens, suppose I have selected randomly, this problem is not there, I have well defined boundary of a town, and I have selected some households. One household I have selected from here in one building. This falls under my when I randomly draw, I got this as my sample. So this house, say I call it house number 1. So house number 1 is selected in the sample, or flat number 1, or household number 1. But when the enumerator goes there to this house, enumerator after one or two visits finds that this door is locked or no one is opening the door. So what he does, instead of taking the information from this, he goes to the ground floor and collect information from another family, and which is actually household number 2, and the result of this is reported by the enumerator in the sample. That means he has done purely a substitution. Now, process and means of substitution are there, but this substitution is done by the investigator as per his own desire. So, ultimately, your sample is once again disturbed. So, these are some incidents, simple examples, so which have a which we can consider as reasons for which sampling error comes and creeps in your study. Sometimes we wrong use of statistic is there. Suppose we should estimate the population mean with the help of the sample mean, but due to some reason, or because of some error, we, instead of using sample mean, we are using sample median to represent or estimate population mean. So this is wrong choice of statistics. So what are the basic reasons of sampling error creeping in the system? First is a defective sampling design. For example, there are some variability in the population. Like some people in your population are rich, some are middle class, some are lower middle class, some are poor, like this. So good, and you know also about their poverty levels, who is at which level of poverty approximately. So For that, a better technique would have been stratified random sampling, so that you stratify your population first and then draw random sample from each strata, so that there is representative in your sample from each strata. But unfortunately, you don't do that. You use simple random sampling because you think that okay, it is easier to administer simple random or draw the sample at least for simple random sampling. That means you have gone with a defective sampling design. Here, stratified random sampling would have been more appropriate. So this is one. Next, as I told, is faulty demarcation. For first example, faulty demarcation of sampling unit. So faulty demarcation has taken place. You have taken the buildings in the periphery, which you should not have included. So there is a faulty demarcation. This is another reason of sampling error. Then is wrong choice of statistics, as I just told. Wrong choice of statistics. Then substitution by the enumerator. So there is deviation of what you estimate from what is the actual. So this is about sampling error. Now let us look at a formal definition of non-sampling error and try to find out that what are the different types of non-sampling error and what are the reasons for which sampling error and non-sampling error comes into existence. So first is non-sampling error is an umbrella which actually takes under it several types of error other than the sampling error. Any error in the entire survey process other than the sampling error comes under non-sampling error. This may arise due to several reasons. The reasons may be in definition. Now suppose I am conducting a survey, I should have a proper on the poor people. So I should have a proper definition of poor people. Now, my country might have given one definition of poor people, which is practiced at different level. But I have given, suppose I have, our country tells that, okay, whose daily income or monthly income or per capita income is less than, say, rupees X. What I did is that I defined my poverty line, that those people whose per capita income or per capita income of the household is less than Y. Now these two definitions are variable and hence there will be some amount of error in my conclusion and it will not match with the standard results that are provided by other surveys done by this is the value given by the government of India, say government of India, and my poverty line is this one which I have given my. So my outcome and the outcome of the government of India will differ. So this is a type of error which is a non-sampling error, nothing to do with sampling. We design a questionnaire. Now the purpose of the questionnaire is to collect that information which will help us to solve the problem or reach the objective of the survey. Those information I will collect which will help me to reach the objective of the survey. Now my questionnaire is defective. It has either not collected some very vital information or have collected some information which is not directly related to the purpose of the objective of the survey. So faulty questionnaire is another reason which helps non-sampling error to come up. Then the approach used, approach of data collection. For example, you have used a questionnaire method of data collection. That is, you are sending the questionnaire to the people by email or by postal mail. But the thing is that most of your population is illiterate. So since most of the people are illiterate, so they are not in a position to answer your question. So in that case, your data is suffering. In that case, your survey results are suffering. In case of that, you are getting a lot of non-response from your observations. So this is one thing. Then we have about this coverage, then information provided by the respondent. Coverage means you are doing a survey, you are not covering all the people, even your sample also actually missing some of the parts which you should have covered. So, and the coverage is poor, or coverage is not adequate. So this is one reason why it will information provided by the respondents. Information provided by the respondents. So for example, income. Income is a very sensitive information. In many surveys, the respondents don't want to speak about their income. Even in census surveys, it is very difficult to extract the correct information about the respondents for their income. If you are a salaried employee, you actually your every penny that you earn is documented. But along with your salary, you might have some extra other side business or side income from which you are earning some amount of money. As per the census regulation, no statement made about income, or no statement made in the survey, in the census of India, no statement made by you in a survey collected by census of India can be used in the court of law or any such government organization like income tax. So if you tell that my salary is this 1 lakh rupees, in addition to that I actually deliver lectures also at different places which give me an earning of say on an average 20,000 rupees per month. So that way my income is 1 lakh 20,000. So these cannot be placed in a court of law, neither income tax can take any action against it. There are strict rules on that. So that this is done so that people can fearlessly provide information about sensitive issues, including that of income. But if you are doing a private survey, but even then people are scared. People tell them, okay, rule is there, but pata nahi what will happen to if I tell the actual information. So they actually don't. Many a times they are a little bit scared. And if you are doing a private survey, then so it is very difficult to collect information on some sensitive matter. So information provided the respondents are not good enough or reflexive of what is actually happening. And then in the process of say data data preparation, data analysis, and reporting. So when a person is in the process, there are so many types of error like tabulation error and other things that comes in. Okay. So these are different types of non-sampling errors that may actually creep into your study. Defining the population appropriately, that also comes here under this. So a response error, also response error, the information provided, the responses, there are two types of error. This is one is inability and unwillingness. What we have discussed is unwillingness. People are not willing to give the response in this matter, and some people have uh, inability also. You may ask some question of which they are unable to remember. Inability. So these are different ways in which non-random sampling creeps into your study. Let us take another slide. Say now let us look at the key differences between sampling error and non-sampling error. So the first point is that when we speak about sampling error, we actually have those type of error which creeps in due to sampling. And sampling error, first point of differentiation is that sampling error is very specific to sample surveys. And not in complete enumeration. And not in complete enumeration or census. However, if we look at the non-sampling error is present both in sample surveys and in case of complete enumeration. So this is the both in sample surveys and in case of complete census surveys or complete enumeration. It is present in both these. Sample surveys are actually performed by selecting a sample from the population. However, census surveys we visit each and every unit of the population. So sampling error is present in both the types of surveys. So uh, this is the first point of difference. Sampling arises because of variation between the true mean value and the sample and the population. So suppose I am trying to it's it's sample it's the difference between difference difference between the estimated and actual value. This is the estimated value comes from the survey of the sample. It comes from the sample, and the actual value is the value in the population. Non-sampling errors arises because of deficiency in and inappropriate process of collecting the data. So this is the main source of error in sampling error. That is difference between the sample value, which is sample statistic, which is used for an estimate of the population parameter. But in non-sampling error is basically coming out of the defective defective procedure defective procedure and then data analysis. This is the type. Non-sampling error can be random or non-random, whereas sampling error occurs only is random in nature. So sampling error is random in nature, whereas non-sampling error may be random, may be non-random. Next we go to a sampling error is mainly associated with the sample size. That is as sampling error is associated with sample size. It is understood that as sample size increases, the estimate, that is the estimate say statistic x bar, will approach closer towards mu as sample size, which is represented by n, increases, or rather goes close to the population size n. As n approaches small n, it is the sample size approaches the population size capital N. That means as the number of sampling units in your sample increases, the value of the statistic comes closer to the parameter. That means one way of diminishing sampling error is to increase the sample size. On the contrary, non-sampling error is not related to sample size, generally speaking, but increase in sample size, with the increase in sample size, it cannot be reduced. Non-sampling error, because non-sampling error, we are not doing any sampling. Rather, what happens is sample size increases, means non-sampling error is that as things becomes bigger in size, it becomes difficult to handle. So many authors express the sampling error and non-sampling error with the help of a graph like this. It tells that as your size of the number of units you study, suppose number of units you are studying, as it increases number of units, the sampling error has a tendency to come down like this. So sampling error will come down as the number of sample increases. However, if you look at the non-sampling error, this is error. However, if you look at the non-sampling error, so yes, your sample size increases, though sampling is not done in non-sampling error. I mean, when your number of units you survey actually keeps on increasing, the things becomes gigantic. You cannot use experts for doing this. You have to include enumerators who are not fully skilled, semi-skilled, give them some training, make them workable, perform. Data is to be analyzed in huge volume. Data is to be retrieved, stored, etc. And so for that purpose, as the number of units increases, there will be tendency of a sample non-sampling error to increase, because you are going with bigger and bigger number of observation studied. So now the total error will be in the total error in the system or total error in the survey is the combination of both sampling error and non-sampling error. That means it will be somewhat like this. That means initially it will decrease because both the values are low in this stage. But after that, as one of them is increasing, the other will also, total error will also increase. Similarly, at the beginning and the top. That means there is some point here somewhere which we need to find out that this is the point, that if the sample size is n1, then even the non-sampling error is not very huge, and sampling error is also under control, or a sampling error is at the means some uh, we can call it that in the this is some optimal value of sampling and non-sampling error, which actually keeps the total error minimum. Since non-sampling error, this non-sampling error is actually dotted line, is present both in sample as well as in complete enumeration. So we can have it in relation to the sampling units also. The number of sampling units, how much is the non-sampling error present? Number of sampling units are this, what is the amount of sampling error that is present. So that way we can actually proceed with this. However, it is very difficult to estimate the non-sampling error. Non-sampling error, sometimes non-sampling error of unknown magnitude may also come into it, but there are different complicated statistical tools which are designed to estimate the amount of non-sampling error. In comparison, sampling error is easier to estimate, and since in case of your sample is randomly selected, then it is definitely quite easier task to estimate sampling errors. So with these words, let us stop here, and hope that you will keep watching other videos. So thank you for listening to this.